In this video, I'll be working through the question you can see on the screen here from the summer 2025 Cambridge A-Level Maths Mechanics paper 4.2. I'm going to try and show you how to do this question and not just the solution. So definitely pause and rewatch certain parts if you need to. If you're looking for a different question from this paper or a different paper entirely, check out the description below. You should be able to find a playlist there or have a look around on my channel. Okay, let's get into the maths.
As is only right for the last question in a paper, question 7 is pretty difficult. There's not too much difficult maths in it. Previous question, we had to do some difficult integration, for example. This time, there's not that much difficult maths, but the idea in this question is hard. So I will try and set it up. If you're really stuck, I'm going to try and give you at first the idea for the question, the idea how to solve the question. Hopefully at that point you can pause the video, try it yourself before watching my solution. So let me explain what it asks first. They tell you about a particle, and it's going up a hill. The hill is on 30 degrees. Particle here, it's shot up the hill. It's set off at a certain speed. Then it comes to rest at the top of the hill, and then it falls back down again. Let me draw 3 pictures because that's the clue I'm going to give you. It starts here, it comes to rest up here, and then it starts falling back down. This guy, he's traveling at 8 meters per second. He's going 0 up here, obviously, because that's the highest point he gets to. He comes to a stop, and then he's coming back down the hill. And this is the one we're looking for. This v speed here coming down the hill. They tell us the coefficient of friction, which may confuse some people because they also tell you they want to do everything using the energy method throughout the question. But we got the coefficient of friction, which we would use for forces and stuff, because we do still use forces when talking about energy. And maybe that's a clue already, which I'll leave out for a moment. Let me set up the energy in each of these systems. There's going to be a difference here because how I would usually do this question is going to be different than what I'm going to show you, because students like doing it the way I'm showing you. So how I'm going to think of this is kinetic energy, potential energy at the start. So the kinetic energy is a half 3 8 squared. That's half the mass, because the mass of this guy was 3, initial speed was that. And then the potential energy. And we'll think of the potential energy as 0 because we're going to come back to the same height. So we'll just think of this as the bottom of the world. How I would do this question is I would just think kinetic energy, kinetic energy, kinetic energy. And I think of potential energy as the work done by gravity. That'll work out a little easier in this question. So if you want to do that, that's probably better. But I will do how most students, I think of it is kinetic energy plus 0 potential energy. This time kinetic energy would be 0 plus kinetic energy would be this height difference between here and here, and that'd be mgh. The g is 10, m is 3, so that's 30 times h, this height here. I think this is how most students think of it, but I just want to point out this energy here is actually just the work done by gravity over this distance between here and here. So you could deal with this later on in the question in a way I'll point out in a few moments. And then at the end, the last state in this, it will have kinetic energy again. It'll have a half m, m is 3, times v squared. And it'll have 0 potential energy. We're back to the height we started with, which we said was 0. Right, that's one way to set up this question. With just one more thing to say. These energies don't equal each other. There's something else involved. There's more work being done. And I think I probably gave some of that clue when I said that potential energy is work done by the force over a distance. Work is equal force times distance. There's more forces involved. To show you that, let's just draw a quick force diagram. Even though we're meant to use energy method, forces are still important. A force diagram would be gravity, friction, a frictional force, a reactionary force here, That's the forces between this world and this world. That's when it's traveling up the hill. Friction's working there, gravity's working here. How does that come into energy? Well, the difference between this state and this state is the kinetic energy should equal the kinetic energy when you take into account the work done on the forces. Potential energy took into account this work. So we still need to take into account the work done from this force here of friction. So we could do that by turning this into an equation. Let's keep all of our equations over here. A half 3 times, well here, let me clean that one up. 8 squared is 64. 64 divided by 2 is 32. 3 times 32 is 96. That's 96 joules here. And that should equal 30H, whatever 30H is. Except there's extra work done. To get from here to here, work needs to be done that beats this friction. That's how I think of it anyway, beating the friction, working against this friction. That work done would be, we could account for that in this equation by adding it here or taking away here. So take away, let's write force due to friction times D. We'll put in D as the length from there to there. So we'll say F1 because we're going to have another force here. Frictional force 1, gravity reaction. There's another one going from here to here. The guy's going down the hill this time. Gravity's still there, and I've already accounted for gravity in my potential energies. But friction this time is going to push this way, and there's still a reactionary force. This time we'll call this maybe F2, although hope maybe you're noticing there's similarities between these F's. F2 here. So we could also put an equation between here and here. We could say 30H. We still have to work against friction. So this 30H should be taking energy away when we go from there to there. We have to work against this friction. So we minus F2 times D. D is the same. We're still going between here and here. This D. And that should equal a half 3V squared. Hopefully that should be enough to set you up in this question. If you were stuck in this question, hopefully this is enough to start you off on it. I'll still solve it, don't worry. But I want to just give you a chance to pause this video and try it again yourself if you were in fact stuck.
If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below.
Okay, how do I solve it? I have two equations here from these energy equations from these two states. But there's a good few things I don't know in it. I don't know F1, F2, D, H, and V, so way too much. I need some things to put these together. I'll put the one that I think a lot of students probably would have forgotten, and it's the easiest one first. D and H are in fact related. This triangle up here is an angle of 30. I can just write, let me do it here and then I'll rub it out because I need the room. I can write sine 30 must equal H divided by D. That's just a half is equal H over D. Rearrange that and I'll leave it up here. I just get D is equal 2H. So they're actually very related to each other. And so that's the first thing I want to point out. I won't use that right now, but it's the first one I want to point out. The important one is this friction force and this work. We need to figure that out. So what is friction? I'll use one of these diagrams and then rub them both out because they're actually very similar. The gravitational force here was 30. Yeah, gravitational force was 30 newtons. I'm going to break that into two forces. One going that way, that'll be 30 cosine 30. And one going this way, 30 sine 30. I really don't care about this one because I've already accounted for the work done by this gravity. It's already accounted for in the way we've done this question. I do care about this one because this will be equal to or. Remember, he's not going to jump up and down of this thing. So this force must equal this force. So this is 30. Cosine 30 is square root of 3 over 2. And that gives me F, because remember I have the coefficient of friction. So this F1, let me put it over here. I don't want to in the way here. F1 is equal coefficient of friction times R, which is equal to square root of 3 over 12 times 30 times square root of 3 over 2. Do a bit of cancelling here. And I believe, I don't know where it is. So let me do the cancelling myself. These go in, become a 3. 2 can go into that 15 times. 3 can go into this 4 times. We'll be left with 15 over 4. That'd be newtons again. That's the force due to this friction. And I'll just, to save me doing any work, this second one is identical. This is again 30 cosine 30. This is 30 cosine 30. The mu is the same. F2 is also equal to this. It's just going a different direction, which I think we already accounted for because we still work against it. So yeah, that's fine. Let me rub these out and we'll leave. We'll just realize we have the force number here. So I can rewrite a lot of this. This equation here, I'm going to write as 96 minus F1 is now 15 over 4. I just don't know D equals 30. I don't know H. But remember, I know D and H. H is equal to half D. Yeah, I've already put D in. So let me change H. 30 times a half D. This is one equation. I can solve for D. And then hopefully we'll solve this for V, would be the plan. Let's see, 2 goes into this 15. So move all the D's over, we'd get 96 is equal to 15D, that's here, plus 15 over 4D. Get everyone over 4, that'd be a 60. God, what's that? 384, I think. This is a D I'm missing here. All the 4's cancel, and we're left with like D is equal, this would be 75D, so equals 384 over 75. What do I have as an answer? I have over 25, so that's divided by 3. I have 128. Is that? Looks about right to me. You multiply that by 3, we get an extra 9. Yeah, that's the same answer. Okay, so I get D is equal 128 over 25. That's meters. That's not what we're looking for. We're looking for this line here, but we have enough for that. If D is that, H, by the way, is a half of this, so that's a 64 over 25. You don't need to have used H. You could have used D the whole time, but I just have H in my answer here. So I have 30 times 64 over 25 minus F2 was the same. Remember, it was the same as this. 15 over 4. D is 128 over 25. All that equals is 1 over a half 3 phi squared. The only thing not known here is phi squared. Rearrange that. I'm going to save myself a bit of time and go to the magic of my notes. And I get 192 over 5. I hope I don't have a mistake in there, because I'm taking a jump here. And then V is the square root of that, which to 3 significant figures is 6.196 something. So 6.20 is, and V was meters per second. That's the final answer. A messy question, but the maths from, like, all this maths was just fractions and rearranging things. It wasn't too difficult, the maths. The difficultness in this question was thinking about the system. Just to reiterate one more time then, you could have done this as just kinetic energy, not have this 30H. And the difference would have been, you would have had to account for the work done by gravity. But the work done by gravity, you would have done it in D, but it would have been the same as 30H, because it would have been, I guess, sine of that, half of this it would have been, which I guess, yeah, it's half of that there. So you could have done kinetic energy, take away the work done by gravity, which would be 15 D, I guess. Yeah, whatever it is. The work done by friction, which we did then finally account for, this times D. Uh, and that's all the D's would have cancelled. You should have got a D. You should have needed this distance there. Okay, I don't think I've explained that well, but these question sevens are really hard to explain because they're not testing your maths. They're testing your problem solving. They're testing, are you able to think of this question and solve it? So hopefully I helped a little at least. If you have any follow-up questions, let me know in the comments. I'll do my best to help you out some more. Thanks for watching and have a great day.